Hi everyone. So today I wanted to go over the review question number 8, especially the part talking about the associative mapped cache. Okay, so before we get started, I want to establish two concepts. The first one is that data is fetched from the RAM by block. Okay, so let's say we want to get the data corresponding to address 200. So the entire block will be fetched. So A and B will be fetched together. Okay. And the second thing is that there is a boundary for the block itself. Okay. You can see here the first block lies from 200 until 204, 208C until 208 until 20C, and so on. Okay. So as you know, we have, it's a byte addressable memory. Okay. So we have 8 bytes. We can represent these 8 bytes as a combination of 3 bits. Okay. So if we want to represent them, so this will be 000, 001, 010, 011, 100, 101, 110, and 111. Okay. So these are all the available combinations. Okay. So if we add, as you can see here, we can take another bit from the tag. Okay. So if we had one more to make them 4, so it could be 0 or 1. So we'll notice that the, the lower limit for each address, you can see it is either ends with 204. So it is from 0 to 4. So this is a certain combination of blocks, and it could go from A to C. So you may notice that this is like a pattern. It's a pattern, it goes all the way until the end of the memory. You may notice that anything that ends with 04 or 8C, okay, so this determines the block end, okay, the end of the block. Okay, so that's how we know the block. Okay, so these are our blocks in memory, and they have the data inside. Okay, okay, great. Next, we will be talking about how things work as we call the different addresses here in our program. Okay, assuming these are our instructions. Okay, we are calling them and they are fetching the data. So at the beginning, uh, as we know, D is the dirty bit. Okay, so in our programs or in our examples, dirty bit will be always 0. It doesn't change to 1 unless we copy or store something into the memory. But in our cases, we are just reading, so all values will be 0. Okay, so let's change them. Okay, let me put 0 here. Okay, so initially this one is 0. Okay, okay, and also initially the valid bit is 0, right? Initially, no addresses are valid. Okay, so everything is 0 here in the initial state. Okay, so this is the initialization, I would say, or the initial step. All the dirty bits are 0, and also the valid bits in the beginning are 0. Okay, no tags are valid. Nothing is valid. Okay, very well. Now we'll get started. Okay, so we'll start reading those addresses one by one, and we'll insert the corresponding value for the tag, for the cache, and for the count. Okay? Okay. So if of course, if the address is found in the cache, so it is a hit. If it is not found, it's a miss. So we start with the first one here, which is the 200. Okay. So we get the corresponding binary address. Okay, so 200 here in hexa. So the corresponding binary address will be this one. Okay, which is our tag, okay? So in this location, we just write that, okay? So here we write 0, 0, 1, 0, 1, 2, 3, 4, 5, okay? So that's our tag. And of course, let me write this down here as well. So for address 200, I'm talking about address 200 now. So because V was 0, there was no valid tag, okay? So this is a miss. This is considered a miss at the beginning, okay? So when we call this address, it's a miss, okay? And then also my counter, because this is the most recent value, okay? So it will be defined or initialized to 0 at the beginning, okay? So one more thing here to notice. So now, after I need to get the corresponding tag from the main memory, from the RAM, okay? So I need to get the data or the values corresponding to this tag, which is over here, okay? And we established the rule that we cannot get the one value only, okay? The data is called by block, okay? So I need to get the corresponding block, the entire block, okay? So I will fetch both. I will fetch A and I will fetch B as well, okay? So A will go here, okay? So now I am filling out the first block, okay? Block 0. So, so let me put A here and B here, okay? So A is here and B is here. Okay, and then also I need to modify the valid bits. Okay, it has to, it's changing now. It became valid. So valid now will be 1. Okay. Next, now we are done with address 200. Okay. Let's move to the next address, which is address 204. Okay. So to get the corresponding tag for address 204, this is actually the corresponding tag. It is already placed here. Okay. So of course, V is initially 0. So this one, this one is already fetched. This is already fetched here. Okay. It is brought here. So if I look at all the available tags in the cache, I will find it. Okay. I will find it. So it's a hit. It's a hit because it is the same tag as this one. Okay. As the previous one. Okay. So now 200 is actually a hit. 204, I mean, is a hit. Okay, 204 is actually a hit. Okay, the counter is already 0, so I don't change anything. Okay, at this point. Okay, let's move to the next address, which is 208. Okay, 208, to get the corresponding binary value, this is the corresponding binary value. Okay, and if I search in all the tags available, okay, all the tags, it is not there, right? So it is something new. Okay, so this means that it was a miss. Okay, 208 was a miss. Okay, so I need to do some changes, right? I need to do some changes. So what I will do, I will change the V into 1. I will place the new tag here. Okay, let me place the new tag. 0. And now I need to, oh, hold on, because the meeting will log off. I need to refresh. Okay. So for this one, 208, I need to grab, as we established the rule, I need to grab the entire block, right? I need to get the entire block. So the entire block will be brought, and it will be placed over here. Okay, so now here I have C and D. They both go here in block 1. Okay, and how about the counter? So now this is the most recent one. Okay, so now this will become 0. The counter here will become 0. And the other counter, this will be incremented into 1. Okay. Okay. Next, let's move to the next address. Next address, which is 20C. Okay. So 20C has this tag, which, as you can see, if we search into the tags available, so it is found here. It is exactly the same. Okay, so tag matches that one. Okay, so it is a hit. Okay, so this was a hit, and for the counter, it doesn't change because this is the most recently used. Okay, this is the most recently used. Okay, okay, let's move to, now we are here, we are in 2F4. Okay, so let's start with this one. Let's place it here. 2F4. So what is the tag corresponding to this? Okay, so need to write the equivalent binary number. Okay, let's write it here. 2F4 equal okay, so I have first 4. Let me write it from here. 0, 0, 1. 0. The place is limited. And then we have the F. 1. And then 4. And then after that, I have the 2. Oh. And 0. Then I have to move this 1, and then 0, and then 0. Okay. So this is my tag. Okay. So if we look into the available addresses, okay, I will not find it. Okay, 2F4, I will not find it. Okay, so this is what? This is a miss. Okay, this is a miss. So now I need, sorry, it's because it's just paint. I'm using paint, so it is not aligned. Let's try to move it. It's not moving. Anyway. Okay, so anyway, so this is a miss. So if it is a miss, we need to implement some changes. Okay. So this has to be updated to 1, right? I need to place the tag right here. I will come here and I will write 0, 0. Okay. This is 4, and then F. Okay, and then 2. Okay. Okay, 2F4, where is it in the memory? It is right here, right? It is right here. So I need to fetch the entire block. Okay. So I'll fetch K and L. I will get K and L at the same time. Okay. So I will come here. This will be my K. Okay. Then this will be here. Here is my L. Okay. So what else I have to do? Okay. The counters. Okay. So the counter, this will be the most recently used. So this will be 0. And I need to increment the other counters. Okay. So I will, this will become, I will erase it. It will increment. It will become 1. And this will be incremented also and become 2. Okay. Okay. Very good. Next, what I need to do, I need to move to the next address. Okay. So we finished to F4. Now I'm doing 2F0. Okay. 2F0. We'll go here. 2F0. Okay. So 2F0, what is the tag for 2F0? Okay, so let's write this down. So it will be 2F0. Okay, its tag will be equal to, I have zeros, 1, 2, 3, 4. Okay, and I have the F, 1, 2, 4, and then after that I have the 2, 0, 1, 0, 0. Okay, do they have the same tag? Is it matching to the previous one? Yeah, it has. It is the same. It's matching to the stack. Okay, so it matches the K, right? But the counter here is already 0, so there is no change. And this is a hit. Okay, this is a hit. Nothing changes. Okay, so we're done with this one. Okay, next let's move to the 200. Let's move to the 200. Okay, 200, it was done before, if you remember, right? It was done in block number 0. So this is actually now becomes the most recently used. So its counter has to be reset. So instead of 2, I will reset it to 0 again. Okay. And the other counters will be incremented by 1. So this one will become 2. And this one will become 1. Okay. And of course, this is a hit. 200. This is a hit. Okay. Okay. How about The next one. What is the next one? The next one is 204. So let's go here. This is 204. Okay. And was it a hit or a miss? It's also a hit because we visited this before. Okay. But 204, as you can see, it was in this block as well, in block 0. And it's already 0. Of course, it was supposed to be reset, but here it is already reset. Okay. So it is 0. It doesn't change. Okay. Okay. Perfect. Next, I will do the next address, which is 218. Okay, so let me write this down. Okay, this is 218. Okay, so 218, what is the tag corresponding to 218? Let's write it down as well here. 218. Okay, so to do it, so it's gonna be this is 0, 0, 1, 0 for the 2. Then I have the 1. Okay, and then I have the 8, which is 1, 0, 0, 0. Okay, okay. So 218, was it in the cache? Do you see the tag here? It is not there. Okay, so 218 is going to be a miss. Okay, so it is a miss. So what shall we do in this case? We have to do some changes. Where is 218? 218 lies, you can see here, it is included in this block. And we cannot fetch, we cannot bring only the G. We need to bring everything. Okay, we need to bring the G and the H. Okay, so we'll place them in the available block. Okay, of course, V, it was 0. Now it will become 1. Okay, this will become 1. And I have to place the tag here. I'll place it right now. And this one will become G. And that one will become the H. Right? And let me place the tag. Let me put it here. Okay, so this will be 0, 0, 1. Okay. Next, how about the counters? This is a miss. We need to implement some changes here to the counters as well. Okay, so this is the most recently used. So its counter will be 0. Everything else, all the other counters have to be incremented by 1. Okay, so this one, instead of 1, it will become 2. This one will become 3. And this one will become 1. Right? Okay, perfect. So 218 was a miss, or 218. Next address, where did this come from? The next one is 21C. Okay, so 21C, was it there? Let's see the corresponding binary value for 21C. 21C equal, okay, so C means 12, right? C means 12. So if you want to write it in binary, we write it like this, 0, 0, and then 1, 1. Okay, and then I have move it, get some space, and then I have the 1. So I have the 1 here, 0, 0, and then I have 0, and then I have 2. So I have here 0, 1, 0, 0. Okay. Look into the tag of the previous one. Was it there? Is it the same? Yeah, it is the same, right? It is the same as this one. Okay. So 21C is actually a hit. Let me make sure that the recording is still on. Okay. Okay. So this is a hit. Okay. But because the counter is 0, there is no change. Okay. Nothing changes. Okay. Let's go to the next address. We have 24. So the last two. I have 24C. Okay. So let's get the tag for 24C very fast. Or get the corresponding binary value. 24C here is equal to, we said C is 12, right? 1100. And then we have the 4, 0. Okay. So this, does it match anything here? Doesn't match. There is no match, right? But where shall we, if we get 24C, so where is 24C? So these guys over here, which have N and R. So this is the corresponding block. Okay. But the cache is full now. Okay. Where shall we place it? We need to replace something. Okay. So we replace it with the block with what? With the highest counter. Okay. We replace it with the block with the highest counter. Where is the block with the highest counter? This one. See? This is the highest counter here. 3. Right? So what I will do, I will get the N and the R. Okay. And then I will replace it with these two. So these will be crossed out. Okay. And then I will put N and R instead right here. Okay. Okay. And how about the counters? What will I do with the counters? Of course, this one right now has to be reset, right? So I have to reset it. This will become, instead of 3, I will reset it into 0. Okay. And I need to increment the other counters. Okay. So instead of 1, I will change that into 2. And this one will become 3. And this one will become 1. Okay. So 20, now we are done. We're doing 24C, right? Okay, we need to write it down. So 24C is what? Change the color. 24C is is a miss. Okay. What about next one, which is here? 2F4. Okay, so now the last one. We are at the last one. That's great. Okay, so 2F4. 2F4 here. How about this one? Is it a hit or a miss? It's a hit, right? 2F4 is a hit. Okay. Why? Because if you get the corresponding binary value to F4, okay, it's equal to, let me write the corresponding binary value, and then I have, make this bigger. Okay, so it was there before, right? And the tag here has to be, we didn't update it, okay? So we just update this one. Okay, this one is 001, okay, 00, okay, and yeah, we need just to update. Next, I have to I update the counters. Okay, I have to update the counters. This one actually, 2F4, was found, as you may notice here, over here. Okay, so this is 0010111, exactly here. Yeah. It's actually the same tag here, right? You compare them. It is the same tag as this one in block number 2, corresponding to the L. Okay. So what are we supposed to do? Okay. What we are supposed to do here? We need to change. So this means that 2F4 is a hit, right? Because it's already found, right? I just need to change the counters. Okay. How can I change the counters? Okay. So because this is the most recent one, okay, let me get a new color. Okay. So this means that this counter corresponding to block 2, okay, will have to be reset. Okay, so this counter has to be reset into 0. And what about the other counters? They have to be incremented. This one will become 2. Okay, this one will become 1. And this one will become 3. Okay. Now we are done with the first round. Okay, let's calculate, let's count number of hits to calculate the hit rate. Let's see how many hits we had. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so hit rate equal 7 over, what is the total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The heat rate is 7 over 12. Okay, and of course, the question is asking about another rounds. Okay, so what you have to do, if there is another round, you have to repeat this sequence one more time, and you have to start with address 200 and again, okay, because we'll start from the first address, and of course, it's going to be there. Okay, it's a hit. So for next round, 200 will be a hit. Okay, but in this case, you see, 200 lies in this block, and its counter in the previous round was 3. So this has to be reset into 0. Okay, and then I have to increment the other counters and then go from there and continue and continue. Okay? Thank you so much, everyone, for watching, and good luck with your exam. Please reach out if you have any questions, and I will record another video for the other type of cache, okay, or the set associative mapped cache. Okay, have a great night.